Hello, everybody. I'm day weather meteorologist Don Day with a winter outlook for you. We'll do our best to show you what we see and what we think may have impacts on the upcoming winter season. And when we talk about the upcoming winter season, we're mainly talking November through February. Now, as you get into March, April, and May, you start looking at different weather patterns. But let's show you what we think is going to happen and why. First of all, we've got a different situation from where we were a year ago. We're going through some La Nina, El Nino whiplash right now. Last year at this time, we were full-fledged in an El Nino. But by February of this year, the El Nino went away and we went into a La Nina phase by spring, which resulted in a lot of dryness and for some of you, drought conditions. You never like to see a La Nina form in spring. You want to see an El Nino form in spring when it comes to water in the western United States. So this year, it's a different setup. Now, this year is somewhat similar to the season before last one, which was that big snowy one for the western United States. That season, we had a La Nina go to an El Nino during the end of winter and the beginning of spring. Well, that could happen again. Not saying it's a repeat of 2023, but it's somewhat similar. The Gulf of Alaska and the northern Pacific sea surface temperature pattern is really critical for Canada and parts of the western and central United States. And we'll talk about those interactions. That always is a big player. The interactions between those ocean sea surface temperature anomalies, what's going on in the stratosphere, and solar activity can have a real impact in winter patterns. Now, this is another thing that's different from last year. Last year we had an easterly, we'll call it a QBO. It's a mouthful there to say quasi-biennial oscillation. But it's something that happens in the stratosphere in the tropics near the equator. And it will go through phases about every 12 months or so, 12 to 14 to 15 months. Last year, it was an easterly phase. This year, it's a westerly phase, and that's important because that's another thing that's different from last winter. So right off the bat, the table being set for the winter season of 2024-2025 is a different table setting than we were a year ago. So what we should expect is not a repeat of last winter. It's not going to be the same. It is going to be different. And it's going to probably be more like the winter of 23 as compared to what we saw in the winter of 24. So what is the current situation with La Nina and El Nino? This is really important. As we have mentioned all the time in our podcast, the largest object on Earth is the Pacific Ocean. The biggest heat content or energy to drive a lot of what happens in the atmosphere happens in the Pacific. So we're very, very interested in the Pacific when you have a weather forecast for the central and western United States. First of all, we have a weak La Nina. It's not nearly as strong as the La Nina that we had in 20, 21, and 22 when we had 3 La Ninas in a row. But it's in place, and it's likely going to strengthen between now and December. It will reach its peak strength. Then it's going to go into a weakening phase late December and into January. Then it will probably be gone by February into March and April. Now, we have seen in years past, when we go from La Nina to El Nino during the winter, especially mid to late winter, that can lead to a lot of winter weather in the West. And we think we're either going to be in a neutral phase with La Nina going away completely. Could we have an El Nino by late spring, early summer? Maybe. We still have a lot of solar activity. We're near the solar maximum, and we'll probably be after the peak of the solar maximum by early next year, which normally you get an El Nino again. So that's something that we're going to look for. This is the current index, and anytime you're at minus 0.5 or lower, you're going to be officially in a La Nina, which is where we are right now. So it's just barely tipped the scales. When it's up here, in this range here, this index, you're in an El Nino phase. So the sea surface anomalies are getting colder near the equator in a typical La Nina fashion. The latest change over the last week of the ocean basins, and this is something we've been watching all summer, is that the ocean basins have been really warm across the globe, but they've also been cooling. Looks like they've reached their peak. And the general trend in the ocean basins across most of the globe are a downward trend. The Indian Ocean in particular, here's your La Nina. We also have had this cooling take place here. The Atlantic has showed some cooling as well. So things overall are on a downward trend. This is the latest sea surface temperature anomaly across the globe. Here's La Nina right there, shows up very, very well. But notice we've got warmer waters here in the North Pacific. We have a current that's bringing very warm waters up by Japan and out into the central and northern Pacific. This could be a player, this pocket of warm water going forward into fall and winter. We'll talk about that here in a minute. So La Nina is kind of hitting its stride at the moment. This is where we were a year ago. So if you compare exactly a year ago from where we are now to where we were in early September 2023, we are in a strong El Nino. Look at that. Very robust. This is how dynamic the oceans are. And this is what you've got to remember. The oceans are changing. They're not steady state. They're going through these different phases all the time, and you just got to do your best to try to keep a handle on it. So again, this is a different table setting than a year ago. This is where we were in 2022. It was a much stronger La Nina than we have now. The North Pacific was also a lot warmer. And this led into the big snowy year of 2022-23, especially in the first 3 months of 2023 in the western United States. So they're similar, but they're not exact. And that's something to remember. You never have the same pattern repeat itself exactly. But some similarities to where we were in 2022 heading into 2023 to where we are now, 24 going into 25. Now, if we were to look at the sea surface temperature anomaly and look at the forecast in the months going forward, this first graphic starts in October, goes to March. This is from the European model. Now, the European model is probably underestimating the warmth and the cold, but I think it doesn't over-exaggerate, which is a good way to show you things. First of all, it shows the La Nina peaking, then fading. If you notice in the last image, March, right there, we see the colder sea surface anomalies going away completely. And you're likely going to see, as the season goes on, this area turning light orange or red as those sea surface temperatures change. Through the course of the fall into winter, we have the La Nina reaching its peak, then fading, but the overall general trend of the North Pacific here is warm. And we're going to go back to this. When we've seen this before, you can have some active winters because you tend to have a high pressure ridge in the winter season want to reside in this part of the globe. And that really impacts North America, as we'll show you here in a moment. So historically, fading La Ninas, warm North Pacifics do tend to lead to more stormy weather. If you do notice, the Gulf of Alaska on the last frame there does show some cooling by spring. By spring, it's less of a factor, but it is a factor certainly when you get into December, January, and February. If you look at the differences between the modeling, this is the climate forecast system, which is a different model than the European model. It's going full guns that will be in an El Nino. This is probably overdoing it. The models will overdo it. It also shows too much cooling here in the Pacific. But the general trend, the message here is La Nina reaches its peak and it fades. So let's sort of put this together and we'll give you what we think the long-term trends could be like. Now, these are the important points to push along here. When you have long-range forecasting like this, remember it's never just one thing. We can never just say, oh, it's just because of La Nina, or it's just because of El Nino, or it's just because a volcano goes off, or it's a combination of things. And this is what makes long-range weather forecasting and climate forecasting really, really difficult, because it's a combination of things, and then the timing of things is critical. I mentioned earlier that when you have a La Nina form in spring, that really affects a lot of the western United States. It can get droughty. But if that La Nina forms after spring or goes into summer before it forms, or before it forms in the fall, that may not have any impact on the spring precipitation at all. So timing is everything. Combinations are important. The combinations of solar, the combination of stratospheric things like the QBO, stratospheric warming events, unexpected changes in sea surface temperatures, which could be the result of, volcanic eruptions. These are things you just can't see. There's things that we know that are going on, like the solar maximum. We know it's going to be a westerly QBO, but there are other wild cards. It's like going to a slot machine and pulling the handle. You might get a couple of sevens, then you might get a bunch of other stuff, and you're a bust. So these are the important points to further on. Remember, we say this all the time, models are helpful, but models are not reality. They're not going to give you the exact. They're going to give you what the trend is. There's also, and this is pervasive in the media right now, online and on websites, there's an excessive overconfidence in the models. That's just the way it is. Models are not reality, so you want to look at trend as your friend. And you want to look at historically patterns that have resulted in other things, such as I've shown you already. Warm North Pacific, a cooler subtropical region, a weakening La Nina with that, has historically had colder winters when we've seen that before. That's something that isn't model driven. Regional differences make a big difference. We point this out time and time again that the continental divide will really play a big role in where Arctic outbreaks go. So for the western United States, if you're east of the divide, your winter is going to be a lot different than folks west of the divide. So you got to remember where you are when I show you these maps. And just the placement of high pressure and low pressure systems during the course of the winter season will really dictate where the cold air ends up, where the warmer air ends up, where the snow ends up. And just a shift of these pressure systems 100 miles or so east or west can make a huge difference in your forecast. That's why you want to take everything that I'm going to tell you with a grain of salt, and a grain of salt with anything else that you see online or what everybody else says. So quickly, let's go over a quick review of the QBO. This can get extremely complicated, but basically what you have is a change in wind patterns in the stratosphere near the equator that moves things around. This goes through a 14-month cycle, but the complete cycle takes about 28 to 29 months. So the cycle of an easterly one last year is cycling into an easterly one from last year to a westerly one this year. So when we take a look at what has happened historically in a westerly phase with the QBO, is that you end up with a stronger jet stream across the northern hemisphere during the winter season. Okay, so a stronger jet stream and a stronger polar circulation can mean stronger storms. Now last year we had an easterly QBO, which means a weaker jet stream. So a jet stream wind that is stronger can lead to more wind periods. It could mean to stronger storms. Historically, now I'm not saying this is going to happen, but historically a western QBO can lead to a mild winter in the eastern United States. Now for the western United States, parts of North America, you can get bigger snows when in a westerly phase. Historically, we've seen that. You also, and this is important for this part of the world in the West, the upper Midwest, the Northern Rockies, California, and I would throw in the Pacific Northwest, you can have a wetter winter. Now, last winter, again, we have a completely different scenario. Last winter, it was the Northern Rockies that did not get the snow. It was the Central and Southern Rockies that got the snow. That's where the snowpack was best. The Northern Plains, the Northern Rockies, it was a bad snow year. The easterly QBO and the El Nino played a role in that, but we've got a different setup. We've got a westerly QBO and a La Nina fading away. That's different. The south and eastern United States historically can lead to drier and warmer than normal conditions. So again, it's a combination of things. Not everything is driven by the QBO. It's just part of the puzzle, but this is what we've seen in the past. So what does that mean when we put together an outlook? First of all, we're confident the La Nina is fading, and the combination of the warmer sea surface temperatures in the Pacific will lead to colder winter conditions in the central and western United States and Canada. I think if there is a really high confidence of a cold winter, it's for you folks in the Great White North. I think really across most of the country, especially from the, let's say, the Great Lake provinces all the way to British Columbia. Alberta, Saskatchewan, Manitoba, be ready for a cold winter. Then obviously for the bordering states of the U.S., that's going to be a factor as well. We're not going to have the extra warmth from El Nino. Without those warm subtropical waters near the equator, we don't have them this time, at least through the winter season, that little effect of it being in some warmer air masses at times during the winter, that's not on the table this year. So we're going to talk about these different high pressure systems in the Gulf of Alaska and northwest flow in the western United States here in a minute. I do think that the rest of September through October and November for a lot of the central and western United States, including central and western Canada, will be warmer than normal. Now, it doesn't mean we won't have Arctic outbreaks or, let's say, cold snaps let's say at the end of September, October, and November. And it doesn't mean we won't see snow. It's just that when you add it all up, I think the look of the pattern from the rest of September through November will be warmer than normal. That is likely going to change as we see the Pacific patterns evolve. The colder weather comes right when you would expect it, the heart of winter, December, but especially January and February. If you look at what's coming over the next 45 days, this takes us through October 20th, you kind of see an explosion of snow cover across the northern hemisphere. You can see that by October 20th into the Rockies here, a lot of northern Canada, the Arctic, but look at Siberia here, the Korean Peninsula, then the high plateau region of China and Asia there. We're seeing a big accumulation of snow. And if you look at North America between now and October 20th, things start to get cracking. And I think these things, when it gets to getting the snow events in the higher latitudes, late September into the first week, 3 weeks of October, things will get going. Now, it all depends on how far south those systems go in October and November. That's why I think a lot of this will be bottled up, at least initially. If you look at the other side of the globe, snow accumulation in Siberia is pretty impressive. This is important because you start to get deep snow cover October, November. This leads to the formation of Arctic air masses that form in November, late December, and January and February. So you're setting the table later on if you're accumulating a lot of snow here in the fall season. So let's take a look at the sea surface temperature anomalies and how that may fit in to the period of December through February, the heart of winter. So here is those colder sea surface temperatures, the fading La Nina. Now these warmer sea surface temperatures here in the North Pacific, what this does is, what I'm going to do is use my cursor here to show that the general trend of what the jet stream may do over those warmer waters like this. This is very idealized. But what tends to happen when you have the warmer water temperatures stay there, it's not real warm here. Don't be fooled by those colors. The water up here in the North Pacific isn't really warm, but it is warmer than the 30-year average with these warmer temperatures. So the atmosphere naturally wants to build high pressure at times over this area during that 3-month period. So the jet stream has to go up, over, and down. So if it goes down into North America, well, you can imagine the air masses coming off the Canadian continent, the higher latitudes spill into the U.S., especially the central areas of the U.S. and parts of the West. So that's why we watch these sea surface temperature anomalies very carefully. Now, if we were to look at the 3 different models, the Canadian model, the European model, and the climate forecast system, this is an indication that the model is seeing that. Again, go back, you can see those sea surface temperature anomalies. So the Canadian model, which I think is actually probably the best model representing what's going on, has got a warm area. Basically, high pressure ridge wants to be there. It wants to be there more often than not. Now, this could shift further east. It could shift further west, and that would really dictate where the coldest air goes. The European model sees it as well. It's not as robust, but it's still there. So the European model and the Canadian model, look at that. They're very, very similar. And when you see similarities in models like this, your confidence levels go up. The climate forecast system, which comes out of the National Weather Service, well, it's got it further north. But from a longitude standpoint, it's pretty similar, okay, when you take a look at that. So there's actually fairly good model agreement for December, January, and February. You don't always get that. So if the high pressure ridge wants to be there, well, the CFS, or the Climate Forecast System model, is showing that for December through February. You can see where the signal's very strong in Canada, across the northern plains into the upper Midwest, while just along and east of the divide, it's a lot colder. What you can surmise from this is that west of the divide, it'll be a warmer 3-month period, December through February. East of the divide, it'll be colder. That continental divide will stop those Arctic air masses all the time. Now, keep in mind, you should not look at this graphic as the gospel truth. This is just a general look, because I'll tell you this, it could easily end up looking like this, where it stays warm in the east. If that high pressure ridge out in the Pacific sets up further west, well, you could have cold air intrusions into the Great Basin. So you got to be careful not to take things for face value. But we're seeing an overall general same message here. cold Canada, cold northern plains, cold northern Rockies into the upper Midwest. But the ability of these colder areas to push further south, west, and east is certainly on the table as well. If you look at the Canadian model, it's singing the same story. Now, it may not look as intense, but it's again giving the same pattern. And the European model is doing the same thing, just not as, let's say the signal isn't as robust, but the European model does very poorly with winter temperatures. But we're seeing a similar situation here. And you know what? This all makes sense. If those warmer sea surface temperature anomalies lead to high pressure wanting to be here during the course of the winter, well, the cold is going to be here. So that's how things are looking in precipitation-wise. See the green and the white. Green and white means at or above average precipitation for that 3-month period. So this is completely different than last winter. The northern Rockies, the Pacific Northwest, then we could probably take the green into here, is going to have a colder, more snowier winter. I think where you have question marks will be more down here because, well, it all depends on how far those intrusions of the cold air go. So where you see the green and the white, you're likely going to have at or above normal snowfall for that period. So it'll be the northern Rockies and maybe the central Rockies, the Pacific Northwest, the Canadian Rockies. Alaska could be very snowy in this regime as well. Now notice California, Arizona, New Mexico, it's drier down there. Now that is exactly what I would expect if that pattern unfolds. This area here, though, don't give up hope, because if the La Nina goes away and we start to get an inkling of a weak El Nino, well, your March, April, May precipitation here could end up being pretty good, and that could end up being further north as well. So this is a completely different winter season from what we're seeing, from what the large players, the big players are going to be compared to a winter ago. So that's our best guess. Hope it was somewhat helpful. We'll probably update something in December to see what maybe that beginning of spring season may look like as we go forward. But that's how we see things. Check back later to see if we were right, wrong, or somewhere in between.